Alright, so welcome to chapter 2, which talks about the diode applications. Now, before you proceed on this chapter, I strongly suggest that you have already mastered chapter 1, which talks about the characteristic and the compositions of our diode, our first electronic device we are going to tackle. Now, for this chapter is divided into 4 parts, so it would be manageable. So the first part is this one. So you expect 4 video lectures for this chapter. So let's proceed. Now the first topic on this chapter 2 is about the load line analysis. Now in here we are going to talk about diodes na as of to how they are used in the circuit. Okay, so before we just talk about the diode and its characteristic, na wala pa siya sa circuit. But now, most of the time, we'll be talking about diodes that is employed on a circuit. Okay, so we have load line analysis. Ano ba ito? So basically, we are analyzing, right, our diode based on graphical solution. Kumbaga, we're using graphical. We are solving this diode here based on graphical. Okay, we call it the load line analysis. So, saan nanggaling yung load line? Ma'am, naiintindihan ko ng graphical because we are going to use graphs. But what's with the word load line? Okay, so sa load line analysis, ganito yon. Sinesolve natin yung operating point ng ating diode using graphs. Okay, so sa load line, we need 2 graphs. First, kailangan natin itong graph na to. Ano ba to? Could you still remember this one? This is the characteristic of our diode. Tama po ba? On your x-axis, you have your VD or your voltage across the diode. On your y-axis is your ID or the current across the current on your diode. So by the way, we call this one our IV characteristic. Okay? Current voltage characteristic because this is graph in terms of the current and the voltage or VI characteristic. Now, this one, saan galing tong characteristic na to? Okay? Sabi dito, analysis of diode can follow one of 2 paths. Pwede using actual characteristics. Pwede yung actual characteristic ng diode, which can be found on some datasheets, or applying an approximate model for the device, or pwede na ma-approximate model lang. Okay, so let's say for example we don't know what is this, whether it is the actual or approximation, who knows, basta as of the moment we know we have this characteristic of diode. Okay, now for load line analysis, ginagamit ito to analyze diode circuit using its actual characteristic. Ito na yun. Okay? We are analyzing this diode based on this characteristic. Okay, again, ma'am, asan na yung load line? Ito na. So, yung load line analysis, ginagamit natin yung characteristic ng diode plus yung load line. Ito po yung load line. So, basically, meron kang characteristic ng device or ng diode. Okay? And then, nagdodraw tayo ng straight line. Kaya nga, line. Load line. Kaya nga, load because this is based on your load. Okay? So, for this certain circuit, our resistor here acts as the load. Okay? Yung power na dinideliver ng ating supply na pupunta dito. Alright? So, yan yung load. So, first step is gumagawa tayo ng straight line. And then, once we have the straight line, we determine kung saan sila nagmi-meet. And then, kung saan sila nagmi-meet, that is what we call the Q point or the quiescent point. Okay? And then, yung point na yun, meron siyang corresponding value on our x-axis or VD, which we will call VDQ. VD because VD naman to talaga tong X basically, and Q because it is the Q point. And on your Y-axis, meron siyang corresponding IDQ. Okay, IDQ yung tawag natin sa corresponding current level niya. So, pag na-determine na natin itong IDQ and VDQ, then we have already solved or analyzed our diode. Okay? Now, before we proceed, go deeper into this one, let's go back to our circuit first. Yeah, so going back to the circuit, dito. Let's analyze whether our diode is in on or off condition. Right? So, tingnan natin. So, meron tayong series circuit, okay? We have resistor here, okay? And one supply. Now, this supply here, this voltage here, would push our electrons. Tama po ba? It would push electrons so that it would travel along our circuit. Now, tingnan natin sa yung flow. So, according to conventional flow, yung flow ng ating current is from negative to positive. Lalabas siya dito. Okay? So, yung flow ng current is clockwise. Ito na yun, yung arrow. And then it goes to our diode. And sabi natin, yung diode is just like a switch which conducts in one direction. So, since dito siya dumaan, then our diode is on. It allows the current to flow. Tama po ba? Okay, so from dito, walang problema. Pass siya dito because yun na nga, it's on the right direction and then it goes to our resistor and then go back again and the circuit is complete. Okay? So, ibig sabihin, walang problema sa circuit. Ibig sabihin, not really walang problema, but on this circuit, our diode is in on condition. Okay? Naka-on siya kasi tama yung direction ng current. So, ibig sabihin, pwede nating malaman kung ano yung values or operating values ng ating VD at saka our ID. Okay? So, aside from that determining the current flow, pwede rin naman nating tingnan, di ba? Sabi natin, the diode would on kung yung positive terminal niya, dito yung positive is connected to the positive side of the supply. Tama ba? Kung yung negative terminal niya is also connected to the negative side of the supply, then we have no problem. So, ibig sabihin, check ng diode, it is in on condition. Alright? Now, going back to the load line analysis, kailangan natin itong dalawang point. Okay, we have to determine this point so that we can draw line so that we can approximate saan banda yung kanyang Q point. Alright? Now, question. We need this line. Saan ba to? If you try to relate it back to our diode, anong value ng ating current dito? ID. Alright, so yung ID natin at this time, dito, is 0. So, ibig sabihin, we will try to analyze this circuit using ID is equal to 0. So, if ID is equal to 0, you get corresponding value of your VD. And dito naman sa kabila, what's the value of your VD? Take a look at your graph. VD is 0. Tama po ba? 0. So, when VD naman is equal to 0, you try to analyze the value of your ID. And then, you got certain values. Then, you connect the dots. Then, you get your Q point. Okay? Is that clear? So, again, itong load line natin is determined by assuming when our ID is 0 and when our VD is equal to 0. Okay? So, of course, to appreciate, we have our first example. So, example 2.1. For a given diode configuration and diode characteristic, determine VDQ, IDQ, and VRs. What is this VDQ and IDQ? This is the quiescent point, or the sorry. This is the quiescent point. Okay, and your VR, voltage to dito. Alright, so load line analysis. Say for example, given ito. Okay, we have here our diode characteristic. Now, we'll determine, ano nga ulit yung determine natin yung point dito, tsaka yung point dito, we'll draw the line, and we get the Q point. So first, we'll have to analyze the circuit. Paano nga ulit i-determine yung point dito? During ID is equal to 0. So when ID is equal to 0, but before that, let's have first our KVL. Okay, magki-KVL muna tayo and then analyze natin using ID is equal to 0 and VD is equal to 0. So for our KVL, let's start here. We have negative E. Oh my god, please excuse my writing. I'm using my mouse. Negative E, and then we have here positive VD. Oopsie. VD. And then plus VR is of course equal to 0. Now, kukunin natin yung VD when ID is equal to 0. And take note, itong ID, this is the current that flows on your Diode, tama po ba? But then this is series circuit, so the current that passes here is the same current that would pass through our resistor. Tama po ba? So, ibig sabihin, ang current na dumadaan dito sa ating resistor is also ID. Okay, so we can replace our VR with, according to Ohm's law, what's that again? V is equal to IR. Tama ba? So, VR is equal to IR. But in this case, our IR is equal to ID. So, yung VR natin is just equal to ID. Okay? Now, at VD is equal to 0. I'm sorry, let's start first on this point. Hanapin natin yung first point dito, wherein at ID is equal to 0. So, when ID is equal to 0, what happens to your VR? Diba that is 0? Okay, that is 0. So, if that is 0, your VD now, if this is equal to 0, your VD becomes what? VD is just simply equal to E. Okay, kasi 0 to, and then transpose natin sa kabila. So, VD is equal to E. So, meron ka ng value dito na E. Say, for example, our E is 10. So, hanapin natin saan banda yung 10. Say, for example, andito si 10. Yan. So, we'll just have to make our first dot. I'm really so sorry about the writing. And next is, let's analyze using ID is equal to 0. I'm just gonna erase this first, okay? So, nare-write ko lang, okay? So, meron na tayong analysis kanina using ID is equal to 0. Now, let us examine our circuit when VD na naman is equal to 0. So, when VD is equal to 0, this becomes 0, and that gives us an ID. I will solve for ID. An ID which is equal to what? What is the value of our ID this time? So, kanina 10 yun, ha? So, our ID this time is equal to, transpose natin si E. So, we have our E divided by R. Okay. Substituting the actual values, our ID is equal to E is equal to 10 divided by, oops, I'm so sorry, divided by R is 0.5. Ooh. It's so hard to use the mouse. 0.5K. Right? And that gives you 20 milliampere. Oh my. Oh, finally. Okay, so here is our 20. So say for example, this is our second point, and if we try to connect the line, this is now our load line. Okay, so there must be somewhere here must be our Q point. Okay, this is not exact so though. So we have on the next slide a more exact graph. So assuming we redraw it again. So this is still the from based on the above examples. This is our characteristic. This is our E. When VD ID is equal to 0, we have 10 volts for our, and when VD is equal to 0, we have here 20 milliampere as our ID, and it somehow intersect our diode characteristic at this point. And if you try to look at it graphically, you can get the value of VDQ of, hindi siya umabot ng 1, so say for example, nasa 0.78 volts, okay? And on this one, it's more than 18 but less than 20, it is somehow, say for example, 18.5 milliampere. Now, these two values now is what we are looking for. And thus, we have our Q point right here. And this is our VDQ and IDQ. And the last requirement is to look for VR. So what now is our VR? So VR is now equal to, diba, V is equal to IR. So what is our R? Given na po yung R natin na 0.5 kilo ohms. And our I is, kasi solve lang natin, our I is 18.5 milliamp. So 18.5 milliampere times 0.5 kilo ohms, that gives you a VR of 18.5 volts. Okay? So, that is how we solve or analyze our diode using load line analysis. So just a recap lang, sa load line analysis, we are using the characteristic of our diode, whether it is, doesn't matter whether it is approximate or actual, basta we have the characteristic and we have to draw our load line. And to determine the load line, to determine this line, we need to have 2 points. So first point, on this part, we can get this point by setting VD is equal to 0. And on this point, we can get this by setting ID is equal to 0. And thus you have 2 points, you just have to connect the point and then you get the intersection. Then the intersection is our Q point, which is what we are looking for. Q stands for quiescent. Okay, this is our quiescent point. So based on our graph, we now approximate values of our IDQ and the VDQ. Okay? Okay, so still, yung ating diode, kapag ka nag-on siya, meron din siyang forward resistance. Okay? But the forward resistance of our diode is usually so small na compared to the other series elements na nasa network natin. So thus, it can be ignored. So say for example, meron tong resistance din. Somehow, meron talagang resistance yan kasi lahat naman may resistance, no? But the resistance of this is so small compared to the resistance of our resistor itself. So when it is so small compared to this one, so usually, the forward resistance here can be ignored. Okay? And also, please do not forget that a diode is on state if the current is established by the applied sources such that yung direction niya is matched, okay, or matches that of the arrow in this diode symbol. And of course, kapag ka nag-on siya, depende kung anong klase siya ng diode. Kapag ka made up of silicon siya, meron siyang 0.7 volts kapag ka nag-on. Okay, I mean, mag-on siya kapag ka umabot na siya dito sa 0.7. For germanium, nag-on siya kapag ka umabot na yung voltage mo sa 0.3. And for gallium arsenide, kapag ka umabot na siya sa 1.2 volts. So, kung sa characteristic tayo, now let's look at this. Based on this characteristic, nag-start ng on ng ating diode more like malapit na siya sa 1. Siguro mga 0.7 to. Okay? So, malamang this is your characteristic for silicon diode. Right? Okay, so yung diode natin, this is application, ano? Yung diode natin pwede siyang naka-series sa ating circuit, pwede siyang naka-parallel, pwede siyang naka-series parallel, depende, okay? Depende sa kung anong design niya sa circuit, ano yung pinagamitan niya sa circuit. Now, we'll try to analyze diode on those different configurations. So, magsisimula tayo sa series diode configuration. Okay, now we'll try to analyze kung ano ba yung mangyayari sa diode kapag ka nagka-series siya. Okay, but before we proceed to example, let us remember first na tandaan mo kung anong determine mo pala kung anong klaseng diode yung ginamit. Kapag ka silicon yan, ganito, kapag ka silicon to, ganito muna yung una, determine mo kung on ba siya or off. Paano malaman? You determine the flow of current, dun lumalabas yung current sa positive side ng ating potential. Kapag dumaan siya dito, same siya ng arrow sa ating diode, ibig sabihin on. Okay. Then, pag nag-on na, you determine kung ilan ba yung voltage drop niya dito. Kapag ka-ideal diode to, walang nakalagay na silicon or germanium, walang ganon, zero to. Okay, kasi ideal. Now, kapag ka may nilagay na silicon, then automatic, this diode here, meron siyang voltage drop na 0.7. So, para bang, wala, parang i-replace mo lang siya ng battery. Parang ganito lang. Okay? Kapag ka na-identify mo na on siya, you can picture this out as just like this, na meron siyang 0.7 volts na kinakain din. Okay? Pagka germanium yan siya, meron siyang 0.3. And then you proceed with the normal KVL or other techniques that you would want to use. Now, what if naka-series siya then na-reverse? What if ganito yung kanyang configuration? So again, first, determine mo muna yung current to determine whether naka-on or naka-off ba yung ating diode. So for this potential, our current is in this direction. Sana ba yung ating So our current is in this direction. Now if you notice, salungat siya sa ating direction ng ating silicon. Wherein, ibig sabihin, This is not conducting. So, parang open siya. Okay? Now, kapag ka-open, what happens to your ID? Meron ka bang current kapag ka-open circuit? May mag-flow ba dito na electron? Kaya bang mag-jump ng electron from this terminal to the other? Hindi. So, ibig sabihin, walang current dito. Okay? Take note class, kapag ka-open circuit, there is no current. So, ang ID natin ay 0. Ayan, tandaan mo lang that ID is 0 kapag ka-open. What happens to your VD? Kapag open circuit ba, your VD is equal to 0 din? Kapag ka yung battery mo ba, hindi mo nilagay sa circuit, say for example, okay, andyan lang siya, nilagay mo sa table, yung battery ha. Say for example, meron kang 9 volts na battery, nilagay mo sa table, wala di bang connection yun? So, para siyang open circuit. Ano? Question, meron ba siyang voltage? Nawala ba yung 9 volts niya? Hindi. Okay? So, ibig sabihin, although open circuit to, still, meron ka pa ring voltage. Okay? So, in this case, yung VD natin is E. Equal na siya dito. Bakit? Kasi 'di ba, based on your KVL, yung supply natin nade-distribute sa lahat ng mga elements dito, ng mga passive. So, tingnan muna natin 'to. Ano ba ang formula ng voltage natin? Dito, VR. 'Di ba VR is equal to IR? Ano yung I natin? ID. So, we have ID times R. Now, yung in this case, naka-reverse bias tayo, your ID is equal to 0. So, pag 0 siya times R, yung VR natin ay 0. So, wala ka palang voltage across your resistor kasi walang current na nag-flow sa kanya. So, saan pumunta itong voltage dito? Kasi kailangan niyang mapunta elsewhere. Okay? So, wala dito. So, malamang andito lahat sa kanya. Okay? Andito sa open circuit. And kung titingnan naman natin sa KVL, it can be proved naman. So, let us look at our KVL. So, kung magki-KVL tayo dito, so maglo-loop tayo. So, anong voltage na encounter natin dito? We have negative E. Okay? Negative E, and dito we have our plus VD. Plus, what is the voltage across this one? VR is equal to IR times V. Plus I'm sorry. Oopsie. Plus, oh my god, IR because this is the, yeah, IR or ID, doesn't matter. Same lang yun sila. Times R is equal to 0. Now, again, we're interested in our VD. But in this case, our IR, which is just equal to ID, is 0 kasi nga open circuit. So, this becomes 0. Now, based on that, our VD is equal to, transpose natin sa kabila, equal to E. Okay, so ito na ngayon yung ating VD. Which just proves this claim that your VD is equal to E. Okay, so that is how our diode behaves kapag ka reverse biased siya. So again, una, help to find or to examine the circuit kung naka-on ba siya or naka-off, and then after that, tingnan mo yung voltage drop niya. Okay? Now, kung talagang okay, let's have this example. I hope kaya niyo na siya, no? So I would suggest, before you dig into this topic, kasi kambal kasi ito sila ng circuits. So, dapat naaral nyo muna yung voltage and current laws sa circuit natin. So, I'm gonna insert video here on how to solve example 2.4 and the rest of the examples for series diode configuration because it's hard to solve on this using mouse. Okay? Before that, source notation muna tayo. Alright, so you can see here, we have our voltage, we have here our battery. Voltage source natin dito is battery, this is DC, this is 10 volts, and this one is 5 volts. So again, sa battery, yung longer side is the positive terminal, itong shorter is the negative. This is just connected to the ground, still connected to the ground. Okay, now, sabi dito, yung E natin is equal to 10 volts. Dito naman, yung ating E is equal to negative 5 volts. Kasi titingnan mo siya, galing dito sa terminal na to, pababa sa ground, ano ba yung sign na na-encounter mo, then, eto, edit mo siya. So, say for example, so in this circuit, so pumasok tayo sa positive, so kukunin natin yung positive sign. So, ang voltage reading nito is positive 10. Okay? Ito namang sa kabila, pasok tayo dito, we enter to the negative, so we have negative 5. Okay?